Hello, today we will learn about function and its classification. So let's start with function. Now, what is a function? So, a function is nothing but from a non-empty set x to a non-empty set y, a correspondence. What do I mean by that? Now, a function from x to y is a correspondence that assigns to each element of x one and only one element of the set y, where x and y are non-empty sets, where x and y are non-empty sets. Okay, so what do I mean by that? Let us understand it by a drawing. So let us say this be x and this be y. So we have, let's say, three elements x1, x2, x3 and y1, y2, y3, right? Let f be the mapping. We have the mapping f. The f be the mapping which goes to x to y. Now let's x1 goes to y1, x1 goes to y2, x2 goes to y2 and x3 goes to y3. Now what do we get from the definition? That assigns each element of x one and only one element of the set y. But here for the x1 it gets to y1 as well as y2, so we get two elements for a single element in x. So we have two images here. What is image? We will get to that later on, but for now we see that for x1 we are getting two elements for their correspondence. So this cannot be a function. This is not a function. Okay, let us say like this. Let x1, x2, x3 be x, and let's say y1, y2, y3 be the y set, f be the mapping such that x1 goes to y1 and x3 goes to y2. Now here what do we get from definition? That are the correspondence that assigns to each element of x. But what do we see here? That the x2 element remain. There is no correspondence for the x2 element. The mapping doesn't assign the x2 element in x. So this is also not a function. So we get the conditions when it is not a function. Let us see some example of the functions. Let's say x1, x2, x3 be the set, y1, y2, y3 be the y. Let's say x1 goes to y1, y2 gets to y1. Now this is a function. Why? Each element of x assigns to a one and only one element. x1 goes to y1, x2 goes to y1, x3 goes to y3. So each element of x is assigned to y or an element of y. Here y2 remain. There is no element assigned to y2, but that doesn't matter. We have to check whether each element of x get assigned or not. So that satisfies, and every element corresponds to one and only one element of y. So this is a function. Okay, so we get what is a function. Now go to the next slide and we will need to know about what is domain and range of a function. Right, let us define a mapping f from a to b. Right, define a mapping from a to b where a and b are non-empty sets. Now this set a is known to be as domain of f, and this b is known as codomain of. Okay, so a is domain of f and b is codomain of f. Okay, now what do we mean by range? Let us say, for that let's say what is image. Let a member, let's let small a belongs to a and f of a is equals to b. Then so what do we mean by that? Now there is an element a in a and there is an element b in b. This f assigns a to b, right? So here this b is called f image of a. So this b is called f image of a, and this a is called pre-image of b. Okay, we get what do we mean by image and pre-image. That's fine. Now what is the range? What is the range? Now range is nothing but a set. The set fa such that a belongs to a. This is range of f. For all. So what? Now the set fa such that for all a belongs to a means what? Now for every element in a where the mapping f assigned to it means what? Like, let's go to the previous slide to understand it well. Now here for this function, let us say here codomain of f is the y set, but the range of f is y1 and y3, because we can see that y2 doesn't have a pre-image, so the range contains all those elements who have a pre-image in x, right? So range and codomain are not necessarily equal. Okay, we get that. So we get what is domain, what is range, what is codomain, and these properties of function. Now there are many kinds of function: trigonometric function, polynomial function. I'm not gonna explain everything, but we go a topic where we have certain classification of functions, right? So let's give the heading: classification of functions. Functions, where we will deal about certain functions. The first kind, let's say 1 or injective function. 1 or say injective function, this kind. Okay, so what is injective function? Now let us define a mapping, a function. Let us define a function f from a to b. This is said to be, this function f is said to be 1 or injective, sorry, or injective if different elements of A have different f images in B. F images in B. So more precisely, how can we write it in a mathematical manner? So let's say by this. Now for x1 x2 belongs to A and f of x1 f of x2 belongs to B, we have f of x1 is equals to f of x2 if and only if x1 is equals to x2. Similarly, we can write for not equals to as well. That means or f of x1 not equals to f of x2 implies or implied by if and only if x1 not equals to x2. So this is injective function or 1 function. So how can we see it by a graph? Let's say this be A and this be B. Let's say we have 3 points. Let's say this, and we have couple of points here also. So here let's say this assigns to this assigns to this assigns to this. So for every element of A, we have every element assigned to B, and for different element of A, we have different images. That's the okay. So we get what is injective function. For different element, we get different images. Simple as that. Let us put one remark which will eventually help us to do some questions. Let's say a function which is entirely increasing or decreasing in its domain, then the function is 1. Okay, we will get this remark to solve some important questions. So let's go through it. Now, oh, I have a slide. Now let's say what is an onto function. Onto or surjective function. So what is onto or surjective function? Similarly, we defined a function from a to b. Okay, let's say if f define sorry, put the black ink. If f defined from a to b such that where a and b are non-empty sets, right? Such that every element of b, that is every element of b, what is b? B is the codomain, right? So every element of the codomain is the f image of at least one element of a. Okay, so what do we mean by that? Now we call, let's do it mathematically. Now let us define f from a to b. A to b, and then f is onto or surjective if and only if for all small b belongs to capital B such that there exists some small a belongs to capital A. Sorry, we don't need to put such that here. For all a belongs to B, there is some a belongs to A such that f of a is equals to b. Okay, so this is onto function. We can understand it by a graph or by a drawing like this. Let's say this be a, this be b. Okay, now let's say this we have these 4 points we have, and let be here 3. So let's say this goes to here as well, this goes to here, and this goes to here. Okay, so you can see that every element of the B, the codomain, have a pre-image. That is, what do we mean by that? Now here, for every element of B, it is the image of a at least one element of A. Clearly here we can see that. Now an important question, important remark, that a function is bijective if and only if f, or the function if the f is 1 1 and onto. Okay, so a function is bijective if and only if it is 1 1 and onto. So is this function 1 1 and onto or a bijective function? No, because for different elements of B we are getting the same images. So let's say this be A B C D, and let's say this be X Y Z. So here, from here we can see that f of A is also equals to X and f of B is also equal to X. So for different elements of A we are getting same values. So f is not 1 1. Right. Now we are done with the theories. Let's do some questions. Then we understand it better. So this is a question of JEE Mains 2019. what is they are saying here now? F of x is defined from a to r, where f of x is 2x by x minus 1. Now what is a? Now, a is x belongs to r such that x is not a positive integer. We have to check whether the function is injective or surjective or not, right? So let's say we have to check its derivative. Let us check its derivative. Why we are doing it, we will get to know. That is, we know the derivative of the u by v method, right? Sorry. So simple calculations, we know the derivatives, how to find the derivatives, and it is very clear. So 2x minus 2 minus 2x by x minus 1 whole square, this is equals to minus 2 by x minus 1 whole square. Now this is clearly less than 0. Why? Because listen, x minus 1 whole square will always be greater than or equals to 0, because when x minus 1 whole square will be 0 only for 1, but we see the 1 is not in the domain. X cannot be a positive integer, so 1 cannot be. For any other value, x minus 1 whole square will be a positive quantity. So it is a positive quantity. We have minus 2, which the negative sign will change it to negative. So f dash x will be 0 throughout its domain. Therefore, f is a strictly, okay, let me not write here because it's not visible. So f is a strictly monotonic decreasing function. Now what do we know? That if a function is throughout monotonically increasing or decreasing, then f is 1 1 or injective, because the function is 1 1 here. Why? Because it is strictly increasing or strictly decreasing. Then we have seen from the remark that the function will be 1 1 if it is throughout monotonically increasing or decreasing, right? So we get from that. So injectivity we have proved. Now we have to check for the surjectivity. Let's see, the function is 1 1, we know that. So let us take a point. Let's say let value be like let's say 4. Okay, so let's say for points like 4, we don't have elements in the domain such that f of x is equals to 4 where x belongs to a. Why? Because when this value will be 4, the value will be, suppose say x is equals to 2, when we put x equals to 2, then f of x will be 4, but we cannot put x equals to 2. Why? Because 2 is a positive integer, we cannot put that. So from that what we can get, now the for points like 4, we don't have an element in domain such that f of x is 4. Therefore what, we find a point in the codomain for which we don't have a pre-image. That means f is not surjective. So f is injective but not surjective. So what is that option? Injection but not surjective, option A. This is the correct option. So option A is the correct. Okay, we get it. Now let's go through another question. Let's go through this, and this will be my last question for this. Now we have a function. What is the function? Now we given that g of x is equals to x square plus x minus 1, and we have composite function here. X is equals to 4x square minus 10x plus 5. Then we have to find out the value of f of 5 by 4, and they put 4 values. This is also a question arrived in JEE Mains 2020. So how can we check that? Now let's go step by step. Easy method. Say g of f of f. This is, we can write like this. Now g of x is what? X square plus x minus 1. So we can write it like what? F of x whole square plus f of x minus 1. We can write like this, right? Now what value do we need? We need the value of f of 5 by 4. Now what do we have? So we get this, and now g of f of x is 4x square minus 10x plus 5. That is equals to f of x whole square plus f of x minus 1. Right? So this means what? We are just putting the value. We know the GOF of x is 4x square minus 10x plus 5. We are just putting the value and this value. For x, we are changing this x with f of x. Right? Okay. Now what the value they want? F of 5 by 4. Just put x is equals to 5 by 4. So f of 5 by 4 whole square plus f of 5 by 4 minus 1, that is equals to 4 into 5 by 4 whole square means 25 by 16 minus 10 into 5 by 4 plus 5. Right? So this means what? F of 5 by 4 whole square plus f of 5 by 4 is equals to, we can eliminate 4 like this. Now simple calculation. Okay, this means what? So 5 minus 25 by 4, just do the simple calculation and we get f of 5 by 4 whole square plus f of 5 by 4. If we do this calculation, we get 6 here, 6, that is, so this is, we get, this is equals to 6 minus 25 by 4, that is nothing but minus 1 by 4. Okay, so this is, we get f of 5 by 4 whole square plus f of 5 by 4 plus 1 by 4, this is equals to 0. Now we can put the Sridhar Acharya formula. So from that we can deduct that. So f of 5 by 4, we know the Sridhar Acharya formula, right? That is what? Minus b plus minus root of b square minus 4ac by 2a. Now this is what? 1 minus 4 get cancel out. So 1 minus 1 is 0. So minus 1 by 2. This is the answer. So option C is correct. You get the question? So option C is the correct answer.